The objective of this lesson is to use the properties of logarithms to solve problems. But the main idea for us to connect on this lesson is that we have to remember that logarithms represent the exponents, and we want to connect these properties to the rules we already know for exponents. So if you can make that connection, because what you're going to see is you're going to see multiplication problems turned into addition. You're going to see division problems turned into subtraction. What I want you to connect here is that's because of the rules of exponents tell us to do that. And since a log represents an exponent, that those rules of exponents are the things that influence these properties of logarithms. So let's start off with, when we do this lesson, to be reminded that the log represents the exponent. So as we tie exponentials and logarithms together, logarithms are the exponent of the problem. So that's really important for this lesson. That's why on this chart, you'll see an exponent rule, you'll see the log formula that ties to it, and then I'm going to do an example that maybe you could do in a simpler fashion using a key on your calculator or maybe even reasoning it through. But I want to affirm what this formula is, this property is tied to the the exponent rule. So let's start off with the exponent rule. We may recall that when we multiply two things with the same base, what we do is we add the exponents. Notice multiplication became addition because this says you have m factors of a and n factors of a, and so when you bring them together, we have m plus n factors of a, because we're multiplying, that's totaling the number of factors that we have. Now this rule, if we turn it into a log formula, I'm going to start with log base a of two things multiplied. I'll call them c and d, and my property here is I'm going to separate those two, make it log base a of c, and then log base a of d, and I'm going to add the logarithms because it's like adding the exponents. Since these logs represent the exponents, they get added when we take this multiplication on the inside of the log and separate the logs. Let me give you an example. So if we were to take a look at log base 2 of 4 times 16, you might know that 4 times 16 is 64, and you might already know that 2 to the 6th power is 64, so the answer to this should be the exponent. That would be 6. But what I want to do is affirm this log formula by looking at this example. This should equal, according to this formula, log base 2 of 4 and log base 2 of 16. When we separate them into two logs, we're going to add those two. Well, 2 to the 2nd power equals 4, and 2 to the 4th power equals 16, so we do get the 6 out of that. So this is saying that we can separate the two logs, as one example, into the two separate logs and adding the resulting exponents together. Let's talk about the quotient property. This is where you have a to the m over a to the n. You may recall with this property of an exponent that when you have that, you go ahead and subtract the exponents. So m minus n, so division becomes subtraction. Well, maybe you're getting the idea of where this is going. If I take the log base a of c divided by d, and what I'm going to do is I'm going to take each of those logs, log base a of c and log base a of d, and I'm going to subtract them because the exponents are being subtracted in the original exponent property. So let's take a look at how that works for an example. So log base 3 of 243 over 3. Now we could reduce that and then do the log if we wanted to, but let's confirm this or affirm this log formula by taking a look at what this looks like with that formula. Log base 3 of 243 and then do the log base 3 of 3, and we're going to subtract the two of them. So the division becomes subtraction. Now, log base 3 of 243, 3 to what power equals 243? That's a 5. 3 to what power equals 3? Well, that's a 1. 5 minus 1 is equal to 4. And if you were to divide these, you get 81. 3 to the 4th power does equal 81. All right, last one we're gonna introduce here is a power property. This is based on if you've got an exponent on the outside of a parentheses. When I bring it in, this is the one. If I were to bring it in, I multiply the exponents. M times n is our property for the exponent. So you have it on the outside, you bring it in and multiply. Well, how that looks like in a log problem, if I have log base a, and if I put c to the d power here, so notice I've got an exponent, something to an exponent power. What that allows me to do is take that d and multiply it in front. This is going to become very handy when solving certain exponential and log problems, but we will be able to use this to solve exponential problems that we haven't been able to solve before by using this property. When you have an exponent on the inside of this, I'm going to go ahead and put this in parentheses even though it's not necessarily needed, but that d comes out in front and we have d times the log base a of c. Now let's do an example here. Let's say I've got log base 6 of 216 to the 2/3 power. Let's see what that equals. Well, first of all, this rule tells us we can bring that 2/3 in front. So take 2/3 times the log base base 6, it's a 6 here, base 6 of 216. You might recall 6 to the 3rd power equals 216. So you have 2/3 times 3, and then 2/3 times 3 just equals 2. So that allows us to take that exponent, bring it down in front, and multiply based on this exponential property, exponent property. It converts into this log property of multiplication. You can bring that exponent down in front. Let's do some examples to illustrate this. Again, many of these examples you could do in a different fashion, easier possibly, but we want to do it here to illustrate our properties. So that's why it's saying simplify using the properties of logs. So the first one here, if I've got multiplication, I'm going to make it the log of the first one. I'm going to make it the log of the second one, log base 5 of 125, and the multiplication becomes the addition of the two logs because it's like adding the exponents. Well, 5 to what power equals 25? That's a 2. 5 to what power equals 125? That's a 3. So I add those two together and I get a 5. If you were to multiply these together and take log base 5 of that, that's what you would get. Let's try this one. I immediately look at this and think of the property above where you have division becomes a subtraction of the logs using the exponent property. And so we make it log base 6 of 216. We make it log base 6 of 36. And the division becomes subtraction of the logs. Logs represent the exponents. 6 to what power equals 216? That's a 3. 6 to what power equals a 36? That's a 2. 3 minus 2 is equal to 1. And if you were to do this, you'd have 216 divided by 36 is 6. Log base 6 of 6. 6 to what power equals that? 6. You get a 1. That's our answer. Let's try these down here, a little bit more complicated. We're going to actually solve problems that have variables in them now, and we want to use these properties in order to do that. So this first one, what I could do this multiple ways, but I'm going to get, in this case, I'm going to get the number over here and this log base 4 of x, the variable on the other side. So what I've got here is I'm going to make it log base 4 of 48. I'm going to subtract this log base 4 of 6, bring it over here with this one, and I'm going to bring this one on the other side, make it log base 4 of x. So by adding it to both sides. So I've not used no properties yet, just the idea, subtract this to bring it over here, add this one to bring it over on that side. Now this subtraction, I'm gonna go backwards on this property. Notice if I have the subtraction of two logs with the same bases, I can divide the two things on the inside. So I'm taking this idea and going backwards on it to produce a single log. So if you look at this one, I'm gonna have log base 4, and I'm gonna put on the inside the first one divided by the second one. That's gonna be equal to log base 4 of x. Now this one here, log base 4 of x, of this, 48 divided by 6 is equal to 8, equals log base 4 of x. Now what you can do is if you have you can use the rule that if you've got logs with the same base on both sides, you can set the insides equal to each other. So I'm gonna put 8 equal to x. That's not dividing by log base 4, that's using the property or the rule that we already have, that if you have log with the same bases on both sides, you can set the inside parts equal to each other. All right, let's try this one. Notice that I've got an expression here where I'm adding two logs. Okay, now I could get these two together and do it. I'm gonna leave it as is and just go ahead and bring them together. So adding two logs means I can take it and make it log of 2x times the 7. Adding two logs, you multiply the inside parts when you bring them together. 2x times 7 is equal to 14x, equals log base 3 of 28. Now once you have the same log base 3 on both sides, same log base on both sides, you can set the inside parts equal to each other. So 14x is equal to 28. Divide by 14 and you get x equal to 2. Now one thing you do need to do, and I neglected to do here, so I'm going to come back and do it, you do need to check your answers. And what you have to check is to make sure that this answer doesn't give you log of a negative or 0. If I put in 2 here for the x, that's a positive number, I'm okay, it does check. Let's go back and check this one real quick. If I put 8 into that, it's not a negative or it's not 0, so this one also checks. And we'll do this last one here. It's going to use the last property of logarithms. I'm going to use the property backwards. Notice what I've been doing here is I've been seeing something in this form and I'm translating it back into this. I just took a subtraction of two logs and I made it into a division on the first one. I took the sum of two logs and I made it multiplication on the second one. Now on the third one, I'm going to have something multiplied in the front of it. I'm going to bring it and make it the exponent on the expression on the inside. So if you look at this, I'm going to be able to take this 3 and bring it up and put it on as an exponent on the end. That's what the rule tells me. So I'm going to have log base 2 of n to the 3rd power, it goes up as the exponent, equals log base 2 of 8. You can put parentheses around this if it helps, just to see that it stays together. Now, same base on both sides for the logarithms. I set the inside parts equal. I'm trying to figure out n to what to the 3rd power is equal to 8. If I take the cube root of both sides, I get n equal to 2. So that's my answer. Let's go ahead and double check to make sure. Is that a negative or a 0 on the inside? It is not, so it checks. So the big idea for this lesson is, let's go back and look at that chart. What I need you to make sure you connect here is the connection between exponents, those properties, and log properties. Because the log represents the exponent, okay, so the exponent on a problem, so when we have an exponent, you're going to have that use these exponent rules, so that means that a multiplication becomes addition because of this rule. Division becomes subtraction because of this exponent rule. And because we have multiplication here, when we have an exponent on the outside, I can bring that down and multiply on the outside. So make the connection between the rules of exponents that we've been using up to this point and the new log properties, and practice those so you get used to them. And then we're going to, in the near future, use those to solve problems that we haven't been able to solve up to this point, either an exponential or a log, because we now have these properties to help us solve them.